Hello, I'm Steve Polaski. I'm at the University of Minnesota, and I'm going to talk about the IPBES Global Assessment. So IPBES is the Intergovernmental Platform on Biodiversity and Ecosystem Services. And the way to think about this is it's kind of like the IPCC except for biodiversity and ecosystem services. And it just finished its first global assessment, and the global assessment was released in Paris earlier in May. And this is a process that, like the IPCC, it assembles experts from around the world to synthesize the science. It's then the governments, this is presented to government representatives, and they have to approve the summary for policymakers. And that's what happened in Paris at the end of April, beginning of May. And it was approved by the governments. And so now there is the first global assessment that's out there. So I want to give you a little bit of background on the assessment process, and then what the main results of this are. So this has been a 3-year process that pulled together a large number of authors from around the world. The format of the assessment was dictated basically by the governments early on into a number of chapters. Each chapter had several, either 2 or 3 or 4 coordinating lead authors. These lead authors were supported, coordinating lead authors were supported by a larger number of lead authors and contributing authors. There were over 51 countries represented, and this was also supported by a technical support unit. In all, so estimates that there were over 150,000 hours of effort put in by these various people to assemble this report. And as you can see, also there's it's not only natural scientists but also social scientists and people who straddle various things and are called interdisciplinary scientists. So for example, I have a joint appointment between an economics department and an ecology department, so I imagine that I'm located in that 9% of people who are interdisciplinary. So what are the main messages from this IPBES global report? So one of the main things that came out of this, and those of you familiar with the Millennium Ecosystem Assessment from 2005, this will be familiar, that nature is essential for human well-being. So nature's contributions to people are vital for human existence and good quality of life. And I'll talk more about that in a moment. And while we are doing a better job of producing food and energy and material, so the kind of goods coming from that have a base in nature, these are increasingly coming at the expense of other contributions of nature to human well-being. So everything from filtering out water pollutants and regulating water supplies, to cultural services, spiritual values, sense of place. And it's not just about people, of course. The biosphere upon which humanity depends is being altered to an unparalleled degree. So we really truly have entered the Anthropocene, where humans are the dominant force of change on the planet. And that has consequences both for humanity and what nature can supply to humanity, but also for the rest of the species with which we share this planet. So biodiversity between species and also ecosystems, within ecosystems, biodiversity is declining faster than at any time in human history. So I will go through each of these in a little bit more detail and sort of tell you a little bit about how we assembled this information and how we came to these conclusions. And in particular, I worked on the section on nature's contributions to people, so I can go into a little bit more depth in that part of the report. But first, why are nature's contributions to people changing, and why is biodiversity being affected? And all of this is being driven by how humanity is changing the planet. So we have literally changed the surface of the earth. So 75% of land area is judged to be very significantly altered. So some of this is for agriculture, grazing, or managed forest, urban land, infrastructure. 66% or 2/3 of the ocean areas have experienced impacts. So this might be bottom trawling, or in coastal areas, runoff of pollutants from the land. It could also be fishing pressures. And then 85% of wetland areas have been lost. So that's an example of a particular and a very important type of ecosystem that has been fundamentally altered over the last 200 years. And this has consequences. It has consequences for human well-being. So these nature's contributions to people, so what nature contributes to human well-being, overall, systematically over the past 50 years, has been declining. So as part of the assessment, we looked at a variety of nature's contributions to people. And again, this is everything from material goods, so productions of food, or of timber, or of fiber, energy, also the medicine supply. So many of the medicines upon which we depend either are directly collected from nature or are inspired by nature, so compounds from nature. But we also depend upon many things that nature does to regulate environmental processes. So this can be everything from filtering out pollutants for air and water, so we have clean water to drink. It's storing of carbon, providing habitat for pollinators, which pollinate crops, as well as other vegetation, controlling pests and pathogens, protecting ourselves from coastal storms and inland floods. So there's a huge range of what we call regulatory contributions. And then also there are non-material contributions. So everything from spiritual values and culture to learning and appreciation of nature, tourism and recreation. So there's a huge range of potential contributions that nature makes to people. But given how we have transformed the planet, most of these contributions to people have in fact been declining over the past 50 years. So this is a figure from the report where we have synthesized from the literature everything that we know about 18 different categories of nature's contributions to people. So most of these arrows are in fact downward, indicating a declining trend in the provision or the potential provision of these services to people. So for example, pollinators. There's been a decline in the amount of kind of natural area close to agricultural cropped area. Pollinator populations in a number of places are noted to be in decline. And that's the reason for why there's a downward arrow in that second row under pollinators. There are a few upward arrows. So for example, in energy and food provision and materials, so many of the things that we have done, we have in fact increased the amount of food and feed and biofuels and timber that have been produced. And in fact, we've devoted more land to food production. But even within the food category, some arrows or some potentials are down. So the stocks of marine life, of fish stocks, have in fact been shown to be declining as a global trend over the past 50 years. So in total, 14 out of 18 of these categories of nature's contributions to people have shown a downward trend over the past 50 years. Now, a global trend can hide significant variation among different areas. So on one of the columns to the right of these arrows, there'll either be a circle, in which case there is the global trend is fairly consistent across regions, or up and down arrows, where there is significant differences in regional variations. So for example, forests have been increasing in many temperate areas while they have been decreasing in many tropical areas. And that gives rise to a number of these different regional patterns. For example, in providing habitat for species in row 1, or maintaining the potential options, maintaining biodiversity in row 18. The previous figure showed potential of nature to contribute to people. So if there's a forest or a wetland, it potentially can provide a service, but that's different than there being a realized service, so what is actually provided to people. So it may be that there's nobody downstream of a wetland, in which case it's not actually providing flood control. But so one way to think about this is, in the report we talked about the difference between potential nature's contributions to people, or potential NCP, realized NCP, output, and impact on good quality of life. Okay, so potential is exactly that. It's what can nature supply. There's a difference between that and realized. So let's use the example of water quality regulation. So the potential is there vegetation there that has the capacity to filter out pollutants from water? Now, if there's no pollutants to filter out, then even though there's potential to do so, there wouldn't be realized NCP. So if we increase the amount of pollution, we may actually increase the amount of realized NCP. So the ecosystem is actually doing more work for us in filtering out the pollutants. But at the same time, the output, which we really care about, which is water quality, may in fact be declining. So realized NCP might be going up at the same time that the output that we care about, in this case water quality, is declining. There's also a difference between the output and then what's the impact on people, what's the impact on good quality of life. And here it depends upon, for example, how many people there are downstream, how do they use or utilize the water resources? Are they taking water directly from the stream or river, or is there a water filtration plant so that might substitute for some of the things that the ecosystem could do in terms of filtering water? So again, we think it's important to distinguish between these various kinds of contributions or impacts, so potential NCP, realized NCP, output, and impact on good quality of life. As you can see, there are various things that come in here, the anthropogenic drivers, the substitutes that potentially human or anthropogenic assets can substitute for some of what nature is doing. However, it's important to emphasize that among substitutes, most NCP cannot be substituted for perfectly, and many of the NCP are in fact irreplaceable. There are not substitutes, adequate substitutes, if we lose what nature contributes. So from the drivers and what we've seen so far of the NCP, it's one of the conclusions of this report is that the basic fabric of life on Earth is in fact starting to fray or is deteriorating. And this becomes really clear when we look at biodiversity. So a large section of the report was devoted to what do we know about how various species are doing, what's the rate of extinction, and the conclusion here is that extinction rates are higher now than in any other time in human history. Of course, in the past, we have had extinction crises, so there have been periods where extinction rates have been very high, but the rates are higher now than at any time in human history. And this chart here shows by various types of species groups, what do we know about rates of extinction, rates of vulnerability, endangered, and critically endangered species. So you can see that there are some taxonomic groups for which the rates are quite high. So looking at the last row, for example, the cycads, the at least vulnerable are over 50% of all the species in that taxonomic group. When you add up what we know, these are the taxonomic groups for which we know the most. But if you add up what we know and what we can conjecture about groups, the extinction rate is thought to be tens to hundreds of times higher than it has been on average over the last 10 million years. And again, from what we know, and here going back to 1500, what is the cumulative species extinction rate? And this is, in fact, way higher than the background rate of extinction of 0.1 to 2 extinctions per million species per year. If you look at the number of species in these different groups and the numbers of extinctions, these are rates. So 2% of mammals have become extinct since 1500, and that's far higher than the rate of 0.1 to 2 extinctions per million species per year. So again, the conclusion here is that the fabric of life is fraying. It's in terms of species, we are losing species and the populations are getting smaller. Virtually all the indicators that we looked at of the global state of nature are in decline. So what is really driving this? And since the period of World War II or since 1950s, many people have talked about what's called the Great Acceleration. So the increase in human activity and rates of change on the surface of the planet, in the oceans, and in the atmosphere. So there are really 5 major things that are causing these shifts in biodiversity and in nature's contributions to people. The first is land use change, and that's probably had the single largest effect to date. Then there's also direct exploitation of species. Third, to date, is climate change. Going forward, climate change will probably increase in its effect relative to other drivers. Fourth is pollution, and then fifth is invasive alien species. These direct drivers are in turn driven by human population growth, changes in demand or in preferences. So for example, in food, it's not just the number of mouths that we have to feed, but we're in fact increasing the amount of calories, effective calories that people eat, because there are shifts in diets towards meat. It takes more calories of grain to produce a calorie of meat that we eventually eat than just directly eating the grain itself. Also important are shifts in our technology and the economic system, institutions, and governance. So all of these things, kind of the indirect drivers, are affecting the direct drivers, which affect terrestrial freshwater and marine systems. We can also look at what's happened in terms of how well are we meeting various targets. So the Convention on Biological Diversity, at one of their Conference of the Parties, they agreed to a set of biodiversity targets to try to be met by 2020, the so-called IPBES biodiversity targets. There's also been the Sustainable Development Goals that governments approved. So there are 17 different Sustainable Development Goals. So the question is how are these changes in natural systems, in nature, affecting how well we're doing at meeting these various targets? So part of the assessment looked at progress towards the biodiversity targets. Perhaps it's not too much of a surprise to see the amount of red and yellow, which is poor or only moderate progress towards these targets, given what we've already talked about in terms of declines in biodiversity. So if there are multiple symbols within a box, that means that there are multiple indicators. So for example, in coral reefs, there's 2 indicators, and both of them are indicating poor progress, basically movement away from the Aichi biodiversity target. Similarly, looking at progress towards the UN Sustainable Development Goals, most of what nature is contributing towards the UN Sustainable Development Goals has in fact been in decline. So the poor declining support column, there are more arrows there. There is some partial support for some of these, for example, the zero hunger or life below water, but there is a column that should be there, which is like full support or increasing, and in fact we found none, no arrows or no categories that fell into that. Okay, well, so that's not a very, it's actually a fairly grim picture of what's been happening to nature over the last 50 years. The question going forward is, what do we do? Are we just going to follow along in that same path, or in fact, are we going to have what the report talks about as transformational change in order to have increases in biodiversity, improvements in nature's contribution to people, or are we going to continue the downward trend? So there was a lot of work in the assessment on looking at various scenarios. One of the things actually, and various policy levers that one can pull in order to try to get us on a different track that improves the outcomes for nature and nature's contributions to people. One of the things that I personally think of as being very important is thinking about what these values of ecosystem functions and nature's contributions to people actually are, and bringing those into our market economies, bringing those into economic incentives so that people actually have incentives to maintain natural systems that provide these valuable contributions. And that's a way to generate not only better ecological outcomes, but also economic and social outcomes. I did not work on the scenarios and policy portion of the assessment, so I don't know those as well as I do the nature's contributions to people. But along with scientists at the Nature Conservancy, so lead author here is Heather Tallis from the Nature Conservancy, and various people from University of Minnesota and other academic institutions, we worked on a paper that was published last year in Frontiers in Ecology and the Environment about, is it possible, is there an attainable global vision for conservation and human well-being? So in other words, is it possible to meet the demands of a growing and increasingly wealthy population while also meeting environmental goals? So reducing greenhouse gas emissions in order to meet Paris climate objectives, to stop habitat loss and therefore stop biodiversity loss, and to reduce water stress and air pollution. So again, trying to meet societal objectives for material production, have enough food and energy and water supply for everybody on the planet to live a decent life, but do this in a sustainable way that also meets important goals like maintaining biodiversity. So in this paper, we looked at two paths. One is a business as usual scenario. So we keep doing what we have been doing. So for example, the next 50 years looks like the past 50 years. So we follow current trends in technology and demand. We meet the economic objectives, but we clearly will not meet the environmental objectives. We'll continue to to blow by climate, have too many emissions, we lose habitat, and biodiversity will continue to decline. We also considered a sustainability scenario, and here what we did was, again, we're going to meet the economic objectives. So we're not asking people to give up on the development part of sustainable development, but we want to insert the sustainable part in it. So we consider both how and where we produce food, energy, and other goods, and we do this in a way which is consistent with the environmental objectives that I just talked about. So we meet Paris climate objectives, we stop habitat conversion, we improve water availability and air quality. I won't go into the details of exactly all of what we did, but basically what we did was to use projections for population, use projections for per capita income growth. Both population and per capita income growth give rise to a certain amount of demand for calories, for energy, for water, and so forth. And the question is, how do we meet those demands and do that in a way that is also consistent with environmental objectives? So the top part of this is showing kind of what we assumed in terms of growth, both of GDP and of population. That translates into, as I said, demands for calories, for energy, for domestic water consumption, and also industrial water consumption. So how do we do that? Well, under BAU, we basically just expand the economy of what we have now in order to meet those larger set of demands. Under sustainability, we back out. We say, well, if we're going to meet, for example, the Paris climate objectives, then that imposes a certain carbon emissions budget. In order to meet that carbon emissions budget, that imposes limits on how much fossil fuel, for example, we can use. So we're going to drop from currently 80 to 90% fossil fuel based down to less than 15% fossil fuel based by 2050. And it's actually a relatively smooth decline is what we assumed in the model. That would enable us to actually hit the Paris climate objectives. And you can see that the atmospheric concentration of 440 parts per million, far less than the 520 under the business as usual. When you do that, air exposure drops way back from what it is under business as usual. By thinking also about where and how we grow crops, we're able to reduce the agricultural footprint so that we actually maintain natural habitat and do not lose habitat relative to what we have today. There's other parts of this where we talk about fishery sustainability and so forth. The bottom line here is that by thinking carefully about what and where and how we produce the things that people want in terms of food, energy, water supply, material goods, we can in fact meet environmental goals as well. So, this was actually a hopeful message. So in all of the gloom and doom that's out there and in fact in the current trends, the point is we can meet sustainable development challenges. We can advance human development and do better for nature at the same time. So it's not so much a biophysical necessity. We do have a finite planet, and that imposes some constraints on us. But the biophysical constraints alone don't prevent us from meeting sustainable development. It's really this interaction of social, economic, and political considerations along with these biophysical constraints that makes sustainable development a daunting challenge. But we hope that at least in this particular effort, showing at least one potential pathway that achieves sustainable development without dramatic trade-offs, without saying, oh, the economy is going to go, the economy is going to tank, that we can in fact do this. We hope to spur our efforts as a global community to undertake the difficult social, economic, and political changes that are necessary in order to make for a sustainable future. So, coming back to the report, the basic conclusions of the report are, first of all, this is the most comprehensive global picture of both nature and nature's trends and how nature is contributing to people that has been produced. So it's building from the base of the Millennium Ecosystem Assessment done 13 years ago, but now there's been 13, 14 years between these reports. A lot has happened since then. A lot of literature and a lot of understanding has changed. Clearly, the trends that we show are worrying and they are not sustainable. There does have to be, the report calls for transformational change in order to make for a world like that we had under the sustainability objective, sustainability scenario, a world where both people and nature thrive. We have to look at what is it among humans and human society, looking at the root causes of why nature is deteriorating and figuring out how we do a better job in supplying the material needs of humanity. So how do we grow the food and energy and produce the energy and so forth, and do this in a way which is in fact sustainable. So anyway, that's a broad brush of what was reported in the IPBES global assessment. Clearly, there are lots of details in the report. The report itself is well over 1,000 pages, it's as one of the authors here, it's both humbling to kind of see where we are and the dangers and the worrisome trends that it does, but also kind of what we know and what we don't know. There are still huge gaps in our understanding of how what we do in terms of changing global systems, global environment, kind of the global environment and our local environment, and how that comes back in ways that affect all of us. So with that, I will stop and thank you for your attention.